In this problem, we're gonna solve the following function. Limit of f of x when x approaches 3 from the right is equal to negative infinite. We have 4 possible options that can satisfy the function. To find the correct answer, first we need to try each one of the functions and see which one applies. We'll start with the first function, which is f of x is equal to 2x over 3 minus x. The main function tells us that x is approaching 3 from the right since it is positive. So we're gonna put 3.001 since it is to the right of the number 3. Now, the 3.001, it's gonna be our x. So we're gonna substitute 3.001 in the x's of the function. So now we're gonna rewrite the function to solve it and write 3.001 in the x's. So it's f of x is equal to 2 times 3.001 over 3 minus 3.001. Now all we have to do is plug it in the calculator to see the answer. The answer in the calculator is negative 6,002, which is almost as if you were saying negative infinite, since 6,000 is a big number. So we have the answer, but we need to make sure that the other 3 functions are wrong. So we're gonna try each one following the same steps. So we're gonna substitute the 3.001 in the x's with each function and then plug it in the calculator and see the answers. Function B is f of x is equal to 4 over x minus 3. So we know that we're gonna plug in 3.001 in the x's because x is approaching 3 from the right. So we're gonna plug in the calculator 4 over 3.001 minus 3. The answer is 4,000. Which is a positive number. 4,000 is a big number, so it's the same as saying positive infinity. We know that the function that we are looking is equal to negative infinite, so letter B is not our option. Now moving on to function C, which is f of x is equal to x squared minus 3. We plug in the 3.001 on the x, which is f of x is equal to 3.001 squared minus 3. The answer is 6.006. So now we know that this function does not satisfy the previous function. Moving on to the last function, which is f of x is equal to x over 3. We're going to plug in the 3.001 in the x because we know that x is approaching 3 from the right, which is the positive side. We're going to plug it in, which is f of x is equal to 3.001 over 3. The answer is 1.00, which is not equal to negative infinite. So we now know that the correct answer is A, which is f of x is equal to 2x over 3 minus x.
Number 52 goes as follows. A retailer in a small city is trying to decide on future expansions of her store. Sociologists at the local university have predicted that the population of the city T in years from now will be given by the function NT equals 40,000 plus 800 divided over T plus 1 squared. Based on this prediction, what is the lowest limit of the population? To start off the problem, we will analyze the function. The 40,000 represents the number of people in the population that can be the least number. The other 80,000 over t plus 1 squared is what represents the change in the population, being the increasing. So to start off, we will write again the function. But now the difference will be is we're gonna put t equals infinity to actually find out what could be the limit of the population. We then add a limit and rewrite the whole formula again. The only change is that we're gonna actually open up the parentheses in the bottom and factor each number, which will leave us with t squared plus 2t plus 1. Now in the bottom, we're gonna rewrite the formula, but now we're gonna leave the 40,000 alone and focus more on the fraction. So now we're gonna grab the number with the biggest value, which would be t squared. We're gonna write all the numbers in the fraction over t squared. So it's gonna be 8,000 t squared over t squared, and t squared over t squared plus 2t over t squared plus 1 over t squared. Now we're gonna rewrite the formula in the bottom, in which the 40,000 will still remain the same, but now we're gonna cancel out certain values. So we got that 8,000 still the same under t squared, but now instead of t squared over t squared, we're gonna have 1, and that 2t over t squared is gonna become a 2 over t. So again, now for one of the last steps, we're gonna take that 40,000, leave it the same, and now all numbers with a t underneath are gonna be replaced with the infinity sign to prove our point that t equals infinity. In this case, all numbers with the infinity sign will automatically be cancelled, which will equal that value to 0. So in the end, we've got what will be 40,000 as our main answer. You may be asking why? Well, it's because since that fraction area gives us what will be 0 over 1, where it equals 0, the 0 plus 40,000 equals 40,000, which means that the limit of population that can happen is actually 40,000.
Our next exercise is to find the slope of a tangent line to the function at the indicated line. Our function is 8 over square root of x at x equals 4. In this case, there is a square root, so what we will do is to convert it into an exponent. So we are left with x over 1/2, but we are not done yet. What we will do next is to move the x over 1/2 up with the 8. And remember, the exponent will turn negative because it was down in the denominator. So we are now left with 8x over negative 1/2, and we can start differentiating. You will multiply the exponent with the coefficient. In this case, it will be 8 times negative 1/2, and then you will subtract the exponent by 1. In this case, it will be negative 1/2 minus 1. We are now left with negative 4x, negative 3 over 2. But remember, we cannot leave any negative exponents, so we will transform this into a radical expression. Now that we are left with this answer, to get the slope, we will substitute the corresponding number to the x. In this case, x equals 4. So we will substitute the 4 into x, and our slope will be negative 1/2.
The next step is to get the y by substituting the x on the original function. Then we get that y equals 4. The next step is to get the b by substituting the y, the x, and the slope in the formula of y equals mx plus b. b equals 6. And last but not least, we find the equation of tangent line, which gives us y equals negative 1/2 x plus 6.